Good morning. A very good evening to all of you. And
Gitanjali, you just share your screen. So
okay, sir. I'm just sharing my screen.
Okay. So welcome all of you for day 6 of session 4. That is the last session for today. So we have an expert, Dr. Gitanjali. Dr. Gitanjali Sharma is an assistant professor in the Department of Electronics and Communication Engineering at Maharaja Surajmal Institute of Technology, New Delhi. She received her PhD in biomedical signal processing from Malviya National Institute of Technology, India. Dr. Gitanjali has been engaged in interdisciplinary research in computer science and engineering, VLSI design system, and IoT application. Her research interests include machine learning, deep learning, biomedical signal processing, EEG-based application, cyber intelligence, and security. She has published more than 30 referred papers in a prestigious international journal and conference, including IEEE Transaction, IEEE Axis, Elsevier, Springer, etc. He is a member of IEEE and a member of IET. Her research works published in a noted international conference and has won several positive praises, including the Best Paper Award. Dr. Gitanjali has been awarded the National Research Excellence Award for her exemplary contribution in research. She has worked as a TPC member and a mentor for a noted international conference sponsored by IEEE and Springer. So, Gitanjali, it is over to you now. Thank you.
Okay, good morning, good evening, everyone, and a very good evening, Amit sir. Thank you for such a nice introduction. So, yes, my name is Gitanjali Sharma, and first of all, is the screen visible to all? A simple Chrome screen, is this visible to all?
Yes, it is visible.
Okay. So I'll start. Thank you so much, Amit sir, for giving me this opportunity to share my knowledge and my experience with everyone who wants to work in this field. So as the sir said, my work area is basically artificial intelligence, machine learning, deep learning. So I'm working in both the fields, machine learning as well as deep learning. And my specific, if I talk about my specifics, so I am basically working with biomedical signal processing. And if I say biomedical signal processing, so see, I have worked in both the datas. Like I have worked with images also, and sound also, and audio. I mean audio, and then as well as signals. But specifically, I am working major. I should say majorly, I'm working with signals. Okay, and in signals also, because obviously when you work, you define the field so that you can work efficiently. So my field is basically in biomedical signal processing. Also, if I talk about biomedical, my specific field is human brain. So human brain is which I have chosen for my working for my research. Okay, so I have published so many papers is one segment, but simultaneously I'm working in many over many diseases, like if I talk about schizophrenia, depression, autism. So there are so many diseases which are related to human brain, and I'm working in almost all the diseases which is related to human brain, even the cancer detection, prediction, everything. Okay, so today when the sir suggested me to present some give some hands-on experience to the viewers and to the audience in this field, so I have chosen this topic of schizophrenia, which is one of my very favorite topic. And because whenever you work in a field, so the most prominent or the most important task in the field of artificial intelligence, because see, on the internet, every kind of help is available for everyone. Okay, and you can take that particular help in the coding, in the execution, everything. But the major obstacle which we face whenever you I know some of you are the beginners, and some of you may have worked in the field. But so the problem which we face while working in this field is data set. Okay, so if you have a data set, so your majority work is already done, because data set availability is the major task which we face while working in this field. Obviously modeling and this is a part, but yeah, the main struggle is the data, because as an Indian audience or Indian researcher, we don't have much option with the data. So I have chosen this topic of schizophrenia, and I'll try to cover all the things related to schizophrenia detection using signal. If I talk about signal, and if I'm talking about human brain, so human brain diseases related to human brain can be detected or can be analyzed through various mediums. Like you can use images, okay, of human brain. You can use signals. So in images also you have MRI, fMRI, and you have CT scans. There are so many formats of images which are available for analyze the human brain. But which interests me is EEG, because there is a reason behind it. Because EEG gives you a specific. I think sir told me that you have already been through the EEG portion. What is EEG? EEG is electroencephalography, which is a kind of signal, which is kind of electrical signal which is generated when the neurons travel in the human brain. Okay, so there is such same as electrons and holes in the circuit. So neurons also travel in our brain, and because of traveling or because of movement of those neurons, there is some electrical signal which is generated in our human brain, and we basically we capture that electrical signal, and then we analyze that particular signal. So it is the best way to find out the any kind of disease which you want to find out of human brain, with very high accuracy. Okay, so I will basically start with EEG only. So first, so when I started working in this field in 2017, that time, because I will discuss that portion also. The first major uh, uh, I should say struggle was to find a machine, because when you work on signals, so signals takes a lot of space. Means my data was in GBs, so a lot of space, and you need a machine which can process this much of space. Because my colleagues which were working in this field, they were continuously running the codes for 48 hours, which is a long time to run a code or process the signal. So then that time I also try to find out a machine means a system, a computer system which can process the data with a good processor. Okay, so simultaneously you but later I found out that you don't need a machine uh, for this, because we have Google Colab. And Google Colab, as you know, it is Colab is also known as collaboratory. Like laboratory, it is same as collaboratory. So Google Colab, where you have ample space to run your code. It is a cloud platform. It is basically based on cloud platform. So you have much space. If you don't have space in your Gmail, you can buy the space. It is also not very expensive. So you can buy the space and you can run your code, which takes around 24 hours to process. You can run that code with the help of Colab within half an hour or 15 minutes, like this. Okay, so I'll start with that only. If you have any doubt, you can write down your doubt in the message box. Okay, seems slides are not there. You no, I have not shared the slides yet, because it is hands on. So I'll share the code directly. Okay, so this is my screen right now. Just a second. This is my screen right now. It is basically a Google page. So first I'll start with Collab. You just write down the Collab, Google Collab. You open a Collab page. So where I have so many codes which I'm working on. So I'll start with a basic code. So you can just click on new notebook. So here you have notebook just like Anaconda and Jupyter notebook, same as. So you have so many notebooks here also.
Yes, Gitanjali, you are not audible right now. Gitanjali, are you there? Yes, participants, am I audible? Okay, I think Gitanjali seems to be missed the connection. Gitanjali, are you there? Okay, let me check with her. I will call her. मेरी वॉइस आ रही है तुम्हें? कॉल ड्रॉप करता हूँ फिर बोलता हूँ, है ना? हाँ, गीतांजलि, मेरी आवाज आ रही है? आर यू देयर? इट सीम्स दैट वी आर अनेबल टू हियर यू. Yes, Gitanjali, are you there? Participants, experts is joining. Okay, there is some issue with the connection, but she is joining. I think she is joining. Yes. Gitanjali, am I audible now?
Am I audible right now?
Yes, yes, yes. You are audible. Please go ahead.
Okay, sir. Sorry for the interruption. I don't know what went wrong.
Hmm.
Okay. Is this screen visible to all? This is the
Yes,
collab window.
yes, yes, yes. It is visible.
Okay,
Please go.
okay, sir. Okay. So we'll start first. We'll start. This is a notebook window, as I said earlier. So this is a notebook window, same as the which we use in Jupyter and Anaconda and any other notebook. So this is also a same notebook. So we'll start with a simple code. So before moving to the code, I'll just show you the data on which we are working. So this is a data which this data is basically in my drive, and I'll extract the data from my drive only. So I'll share the link first. I'll share the screen of my drive so I can show you the data. Okay. So as you can see, so here this is a concatenated data. There is one folder in my drive only, concatenated data. So if I open this folder, yeah. So if I open this folder, there are two folders. Okay, there are two subfolders, normal and SZ. SZ is basically, yeah. So SZ has all the file of patient who are suffering from schizophrenia, and it's their EEG file. So what I have done, file into CSV to process it. Okay, and the other folder in this concatenated data folder is this normal. which has all the files of the people who are normal, who don't have schizophrenia. Okay, so there are so many files, as you can see. There are around 19, more than 19 files actually, for normal patients and for normal people and for schizophrenia. Okay, so this is to show you, okay, this is the data which I have stored in my um, drive. So if you have data, you can store the data on the drive, because obviously machine does not have so much space to store. So you can directly store the data on the drive, because anyways you are going to buy the space to run your code, and it is not very expensive. Uh, it is very affordable. Okay, and now I have opened the screen of notepad this notebook again. So first I'll start with a simple um line to show you that how basically we are working. So this is a simple command of TensorFlow version 1.0. So if I run it, to run it, either you press the run button or you can use shift and return altogether to run the code. So I'm using here shift and enter to run the code. Now it is not working. So because I have intentionally used this to show you why this is not working, because earlier when there was version of 1.0, then that time version 1.0, now if you don't know what is TensorFlow, so I'll just give you a brief. That TensorFlow is an open source machine learning or deep learning framework, which was again developed by Google. Okay, and it is mainly used to train or build neural networks which support machine learning and deep learning. Okay, so tensor means multi-dimensional array, and flow is basically a graph. Okay, so that's why it is called TensorFlow, which has so many libraries, which again help you in writing your code. Okay, so it is for any, it runs on CPU, it runs on GPU, it runs on TPU, if you have very fast, if you need a very fast hardware. Okay, so but now the TensorFlow version 2.0, so now your collab is compatible with 2 version 2. So I'll edit it and then I'll run it again. And now it has extracted the TensorFlow. Okay. So this is my first line of command. So I have taken the TensorFlow. If you want, you can take this command. If you don't want, you just skip this command. This is not necessary. I have intentionally included it to show you that, yeah, this is what this, if you don't work on collab, you can use it. If you are not working on collab on any other platform, you can use this to install TensorFlow or to take TensorFlow. Now the second line of command is what I'm doing. I'm importing TensorFlow as TF. Okay, because what I'm testing, that whether this machine has TensorFlow or not. So this is for testing. This is a simple command. It is again optional. So I'm running it. Okay, now the next command is this. Okay, so now what is this command? So this command is not koi rocket science. It is not a rocket science. So this command is basically um, from Google Colab. So what I'm doing, I'm taking, basically I'm Google with Colab, and I'm importing the drive, because my data set is in the drive. So I'm importing the drive, and in drive we have content and drive. So I'm mounting the drive here to extract the data, and I'll run it. So to run it, it will ask your permission to get the access of Google Drive. So you have to give the permission to access the Google Drive. So I'm giving the permission. Okay. So I have given the permission to access my Google Drive so that it can extract your data. So now it has basically extracted your data. Now, see. So what I'm doing, see, it is very easy and it is common for all the codes, which, see, what I'm gonna give you an example, or jo bhi, whatever I'm gonna do is basically, it is enough for you all to run your code or to run your data. Okay, it is enough. So I am taking a very simple kind of code or commands which you can easily use. Okay, so this is basically, first command is import numpy as np, which is basically a common line of command. Key, what I'm doing, I'm importing the numpy library and pandas. Numpy we use for mathematical operation or linear algebra operations, and pandas I have basically written it also as hash. It is for linear algebra, and for data processing we use the pandas library because it has inbuilt functions, so you don't have to write the complete code, or to you don't have to write the complete function to form an operation. It has inbuilt commands, and you just take the command and you basically run your code. And then we have this Keras is again a library which you use, which also has so many operations. So this is simple functions which I am extracting, and I'll use it later on. So I'm extracting this Keras for categorical option, because I have two categories, normal and schizophrenia. So this is for classification. Then I have sklearn model selection, and from sklearn model selection I am importing test train split, because obviously I'm gonna divide my data into training data, because I believe you all have the basic information about the machine learning and deep learning, what and or the classification. So basically whenever we do the classification, we have to divide the whole data into training set and the testing set. So this is for that purpose. From sklearn model selection we are importing train test split function, which we'll use later on. And from MATLAB, this matplotlib, we are using plt is basically to plot different kind of graphs, which will be used. Random again we'll use later on. And os. Okay, so these are the basically functions which we are going to use later on, and I'll explain all the functions when I'll use to run this code. Okay, this is, so whenever we run this code, it it give you this tick operation. Okay, this code has been run, otherwise it will give you a error. Now this is the next command, which is import glob. So now what is this glob? Glob is again to take the access of system, operating system. जैसे हमने same as we took this OS, we imported OS for the same purpose. So here also we are importing this glob. Just a second. Okay, now the next. Okay, this. So this is listing, ls. Okay, listing, content, drive, my drive, concatenated data, and then in the concatenated data folder I am taking the data. Okay, so this is basically a command. So this is what I'm doing. This is I'm giving the path. I'm giving the path to my data, so where my data is basically stored. So I'm taking the path, and I am taking the folders out of that particular data, because I have to access those files to process. So I am basically listing the files in the directory. In very simple language, I'm listing that particular files which I'm going to use in the directory. Okay, and I'll run it. Okay, so as you can see in the concatenated data folder, we had two folders, normal and sz, which is showing it. So it is showing that it has two folders, normal and sz. So this. So the path which we have defined in the directory, I am extracting that particular file, those particular files, and storing in the data. So I'm basically storing the data. I'm defining the path to the data set, so that whenever for the next time when we use or we want to extract that particular data, we just use data. We don't have to use the whole path. So we are basically defining the path to that particular data set. Okay. Now we are defining categories, because we see the folders which we had in our drive, in our Google Drive was normal and SZ. But here also, whenever we analyze the data, we also need two categories. Otherwise, the machine will know that which one is normal and which one is schizophrenia. So whenever they see, the machine works on the mathematical portion. Okay, so this is whole mathematics. So whenever we analyze the data, we have to do some sort of mathematics for it. So to perform the mathematics, the easiest option, because we all have learned C++, so we all know that the best way to perform any kind of mathematical operation on the data, we have to use arrays. Okay, so what we'll do, basically we'll take the data and we'll store those data in the arrays. So here we are defining two different categories. One category is for normal data set and other categories for schizophrenia. So this is to define the categories. So basically I'm taking normal and SZ and we are basically defining the categories. Or in other language you can say that we are giving the labels, because we need labels whenever we do the classification. So in the classification there is one X and Y. X is basically the data which you have, and Y is the labels corresponding to that particular data. Suppose you have 20 files. For an example, you have 20 files of a normal patient and 20 files of schizophrenia patient. So you have labels. So you have total 40 files, 20 of schizophrenia and 20 for normal. So you will define the labels corresponding to each file. So normal level 0, schizophrenia level 1, normal level 0, schizophrenia level 1, like this. Okay, so whenever the machine, because when we'll feed the machine with our data, we have to give some data for the training purpose. So in the training purpose, what we'll give to the machine, will give the raw data, and corresponding to that particular raw data will define that for this X, this is the Y. So that machine will know कि yeah, this particular X is corresponding, I mean this particular Y is corresponding to X. So this machine will know that yeah, this particular data is for a normal patient and this particular data is for schizophrenia patient. So suppose we have 100% data and we are using 70% data for training purpose. Okay, so for training purpose means that we are giving that particular data to the machine, and machine knows ki, yeah, this is the data of normal patient and this is the data for schizophrenia patient, and this machine will teach itself as per the data which we are giving. So next time when we'll give the machine a unknown data which this machine has not been trained, so she'll be able to tell this is the data of normal patient or this is data of schizophrenia patient. For this purpose we need to define the data with labels. Okay, so this is for that particular purpose, that we are categorizing normal and schizophrenia patient, and then we are giving basically some sort of labels to it. So I have already written my code, because obviously time was not because we have only 1 hour of time, so I cannot write a code at the time of this at time of presentation only. So I have taken my code which I have worked like very first. Okay, so here, so what I'm doing here we have a training data. I have defined initializing a data list. So basically we have a data list and I'm initializing that particular data list with the training data. Okay, so this is for that purpose, and it will store the data sample and labels as per the definition. So here it is. So I'll tell you the complete code, what I'm doing here line by line. Just a second. What I'm doing here, I'll just tell you. Okay, so here we are. If you have any doubt, you can ask me in between also. If you have any query, no problem. Okay, fine. Okay, no query at all. So first is the training data is equals to bracket. So this is a basically a empty list. So this is, I am basically creating a list with the name of training data, and which is be empty because we'll store the data later on, and it will basically store the data in the form where in the previous line which has the categories equals to normal and schizophrenia. So similarly it will also store the data and the corresponding label to it. Okay, so now the second line, it basically define create underscore training underscore data. So which is basically define a function. So basically here I'm defining a function create training data. So when it is called, it will load and prepare the data set for that purpose only. Now for category in categories, for category in categories, so it is a loop which will go through each category in the list category. So here I have defined a list categories where it has two normal and schizophrenia. So basically I have to access in simple language, what should I tell, that I have suppose 20 normal data, 20 files of normal patient and 20 files of schizophrenia patient. So whenever I am accessing, because I have to access the data set, right? So and I have to access the data set, I have to prepare a list also. So I am going through a loop for category in categories. So in categories, whatever data is there, it will go through the example. For an example, are, suppose we have two categories, normal and schizophrenia. So it will first process normal and then schizophrenia. Okay, like this. So different categories, whatever we have defined. Now next is the path is equals to os, as I said, that for the operating system, dot path dot join data and categories. So it basically it will join the base folder, which is the data folder which we have defined earlier, and the current categories to create a full path name. Okay, because we'll use it later on. So for an example, data is equals to, we have a data is equals to normal and schizophrenia, like that. Okay, so it will add data set oblique normal, data set oblique schizophrenia, like that. Now next is class underscore num is equal to categories dot index bracket category. What it will do, it will find the index of current category in the categories list. Suppose I am accessing the fourth number of category, so it will find the index of fourth category in the categories list. Okay, so is this the zeroth or the one first, like this? And the number in the label is, this number in the label is a class underscore name. Now again, for file in os dot list directory path, so it will again a loop which will go through each file inside the current category folder. Suppose I have the data normal, so it will iterate over all the normal files, then try. It will read, because I have as I showed you earlier, in the drive all the data files were with the extension csv. Okay, so that's why it is define is equals to pandas. Pd is for panda. I have used it used pd as a panda as a pd. Okay, so it is, pd means it is using pd panda library dot read underscore csv. So it is basically reading that particular csv file which we have just defined in the categories. Okay, index through indexing. So it is basically reading that particular file. Now data one np dot array bracket define. So this is np is for numpy dot array. So it will basically, what it will do, it will convert the pandas into numpy array for numerical processing. So basically what we are doing, we are creating an array for numerical processing, because we are going to do numerical processing. Now the next line is training data dot append. So what, suppose I'm taking index 0, then index 1, then index 2, so it will append the data into the training data list. Okay, otherwise there is, if there is no data, then exception and pass, and it will create last, at the last it will create training data list. Is this clear to all? I have defined, I have explained each and every line. So it will append means it will enter the new entry into the training data list, and each entry is like data and then class. So we have two entries in the training data. One entry is the data one, which we have defined here. Data one is equals to np dot array, and the another. So it will be like this. In the training data, we have two elements. One is the data one, and other one is the class num, which is for the data one is two, which is converted after numpy, which is converted into the array, and to which matlab, to which category it is basically belongs to, it is defined by class underscore num. Okay, it is easy. And if there is an exception is for if there is error while reading a file, or it is some sort of corrupt file is there, or wrong format is there, it will be ignored, or it will crash the loop, and then at the last it will create the training data. So I'll run this and let's see if there is an error or not. So while this code is running, I'll just explain again. So this code is very simple, which I have just written. This code will go through each category folder. So there are two categories, normal and schizophrenia. So this code will go through each category folder. It will read the CSV file inside it, convert them into NumPy array, and correct to the and then attach the file to the correct label, like 0 for normal and 1 for schizophrenia, and then store everything in the list. Is this clear to all? In very simple word. Am I not audible? Someone is writing. I'm not audible. Am I not audible?
No, 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 no. You are audible. You are audible.
Okay. Okay. So I'll repeat it again if because while the code is being processed, because I cannot run another line before that, because see, it is again moving. It is moving in circle. So I'll read it again. So what this particular code will do. So where here we have a training data list, and we are storing two elements in the training data list. So this code will go through each category folder. So we had two categories, normal and schizophrenia. It will read the CSV file of those categories, those folders. Then it will convert these CSV files into NumPy array, and it will attach the file. Suppose it is the normal category file or it is the schizophrenia category file. So it will attach the file to the corresponding label and then store in the training data. So then in the last, what we'll have a training data list which has which will have the your normal CSV file or the schizophrenia CSV file corresponding to a label, in very simple language, because we need a list like this, where we have on the left side we have the data, and on the right side we have a label. Because when you went through the theory in the theory, it's like this only, that there is a list where we have a data, and corresponding to the data we have labels. So this particular portion of the code will do that. Okay, so it is still running. Let's wait, because data is huge, so let's wait. Mm. See, on the right side also you can see here you can see that the system RAM, it is using 2.9 GB. This space, it is using 40 GB, and this is only possible because I am using a cloud space. If I would have been using this, what should I say, the machine, so it was not possible. It would have been not possible if machine space was there. Just wait. Okay, now it has been run, and there is no error. Thankfully, there is no error. So now the next. So this is print. So what I want to see what is the length of training data. How many files we have, basically how many files we have actually in the data. So I just want to see that. So I'm printing it. So there are 1110 files in my training data. It is very simple command. You just print the length of the data, and it will show you what is the length of the data. So it is for that particular purpose. Now the next command which I'm using is this. Okay, so I am importing as you has this here. I have already import random, okay, from Keras, because random is a function. Importing again, you can skip this also here. You can directly write random dot shuffle training data. So what it will do, it will shuffle, because it is extracting the data from the drive. So what I'm doing for a fair analysis, I'm just shuffling the data. Very simple, nothing. So you can skip this portion also, importing random, because we have already imported it, and you can just write down the simple shuffling wala command. Now, now this is the next command. For sample in training data, bracket colon 10, print sample 1. So what it is doing? So it is, so we basically, as you can see here, training data. So we had a list training data. So it is basically accessing that particular training data. And column 10 means it is slicing the 10 elements, first 10 elements of training data. So we have prepared a list of 1110 elements, and it is slicing off the first 10 elements of that particular training data list, because we had so many, we had more than 1000 samples, and we are slicing off the 10 samples to see. And then we are basically running a loop over those 10 entries. In the first entry it will be data 1, second entry data 2, third entry, and we are printing it. So let's see what will be the output. See, this is the output. So that means 0 is for normal, 1 is for schizophrenia. So that means it is showing that the first entry of the data is for normal patient, second entry is for normal patient, third entry is for schizophrenia patient. So that means we are doing the right job. Okay. Now, next is this. I'll run it. Now this Google Colab has incorporated Gemini also. So it is now, the job is very easy, because see here it is showing start coding or generate with AI. So you can just write down what you want to generate, and it will help you. Obviously it will not give you the complete code, but yeah, because data is yours, so the whole portion is of data. But yeah, it will help you a lot while writing out the code. So it is still running. So I'll just give you a brief what is it is doing. So again, it is importing numpy as np. Again, you can skip this because you have already imported numpy as np. Now x and y it has taken, because we have already discussed training data wala portion. So you might know what it is doing. There are two x and y, two empty list. Okay, that will store the features. So x is for storing the feature and y is for storing the labels. So why I'm telling you that access for features, because the data which we are using are basically features only. Okay, because I'm going to use deep learning. So in deep learning you don't extract any feature specifically, you just run the data, you just run your code over the data. So the data itself is a feature. So x is basically to store the feature, and y is the for the corresponding your labels. Now the next line is real underscore data. It has all, yeah, it has been run and no error at all. Okay, so I'll explain this. Real data, so I have taken one more variable. Real data is equals to np dot zeros 11106249.19, because this is the size dimension of my because what this is doing, it is again using numpy library dot zeros. So it is real data. It is creating a 3D numpy array which is filled with 0 initially, with the shape of 1110, 6249 and 19, because I know what is how many files we have. Because whenever, if you want, I can show you by opening the any csv file, because I have to stop sharing the screen, and again I have to share the screen of my data. I'll show you at the last. So what does it mean? It means there are total 1110 files. And when you open a single file, suppose you open a csv file, so in the csv file there are rows and columns. So it is saying that there are 6249 rows in that particular csv file and 19 columns. Okay, so there are total 1110 files, and in each file there are 6249 rows and 19 columns. So it is basically, this real data is an empty 3D numpy array, which is initially why I'm writing it like key np dot zeros, because initially we are filling it with zeros because we don't have anything till now. So we are pre-allocating spaces with zeros. Now we are taking p, I, and ii, three variables. Basically, these are counters, and we are initializing this counter with zero because we'll be using it. Now, while while p is basically assigning length training data. So it is again, while is a loop, it is going through each sample p in the training data. Initially p is nothing but zero, but it will obviously will be incremented one by one. So initially what this loop will do, it will go through all these samples, each sample p in the training data, and then it will store the sample index p at the real data which we have created initially with zero. So it will store the sample index p in the real data. Now in the while loop again, it has another while loop. So it is an inner loop which will again iterate. See, while I 6249 I length training data p0 which we have just used minus 1. So it will again an inner loop which will iterate row by row I over the data from the training data p0. It was initially p0 only, and it will stop if this I is reaches to 6249 or the length of the sample data, which is the smaller, whichever one the smaller, it will stop there. Then it will save the current row index I, which is the I. It will save this I into real data pi0. Okay. Next, again, again a loop which will throw each item, element or column, you can say, of the each row I plus 1 in the sample data. It will skip the very first item. It is it is written like that. If I is equals to 0, means it will skip the very first item if I is equals to 0 and then continue, and it will fill the remaining values into real data. So basically, essentially what it is doing, it is copying the value from the CSV data into the big real data array while ignoring the first column. Then p is equals to p plus 1, moves to the next sample. Then for item in the training data, x append item 0, y append item 1. So x for all features array, item 0, y for all levels, item 1, and it will then print them. So, and x is equals to this real data and print x shape. It is for shape, to see the shape. So it is printing three items here. As you can see, print length of x is 1110, length of y is 1110, and print shape. What is the shape of x? Real data, which, because real data was, what was real data? Real data was your 3D numpy array, which was earlier empty, but now with each iteration we are basically storing the data, and we are basically taking the data from our CSV files, and then we are storing in the this 3D array for the next processing in the real data. So the shape of real data list, real data array, 3D array is 1110, 6249, and 90. So that means we are going right. So again, in simple words, what it is doing, so this code is taking your raw data which we have stored in training data list in the form of data and labels. It will reshape it into a 3D numpy array which is named as real data, and then set x to the array, and y will hold the labels. So now you have x and y ready for the machine learning. So x is features and y for labels. Okay. Now the next set of code is this. Before that, what we can do, we can see that what we have. So we'll just take the first x0, and it will show you this is the data in x0. This is the array for x0. This is your x0, and it is not giving any error output, so it is good. Now this is from SCI Pi, which is again SCI Pi is the again a library from which you are importing stats, which we'll be using next. So now the stats, as you can, is equals to stats dot z score bracket x. So what it is doing, it is doing the z score normalization, because see, as you can see in the because I have just taken the first x0, and you can see the data has a variation because one value is 7.49 something something and other value is minus 3.05. So we have to do the normalization, and the most successful and most famous normalization is the z-score normalization. So I'm taking here, so from stats I'm just using the function z-score. You don't have to write any code for this. You just use the z-score function for z-score normalization and you just run it, so it will do the normalization. And now you can see after the normalization the data will be like this. So it is our normalized data which is in the range. This is why we are again creating an array for the labels also. So you can see what is in the y is basically for labels. So if you see here, if I check this, so it will give you, just a second, np dot instance 64. There's something array. There is something wrong with the code. Just a second. Append items, real data, training data. Some keywords might have changed, I think. I'll check it. No problem. Y10 np. It is not giving you the value. There's something wrong. Append training data. Some keyword might have changed, I think, because it is the updated version. Just a second. Array. Okay, we'll see later on. It will give you error and we'll check what is the error. We'll just check. This is for time steps because I'm taking another this yeah, where were we? N underscore time steps is equals to 6249. So basically it is defined the time steps because it will be using it later on in our code function. You will now this is next command for, so we are defining the train test command. So for training also we need x for training. X will be needing in the training and y will be needing in training and testing both. Similarly x. So we are defining this command. This is a predefined command. You have to use it like this only. And here I am defining the test size is 0.25. That means 25%. Okay, test size is 0.25 and I'm splitting the test and training data. Just simple. And you can define, suppose you want to take 30% of testing data, you can use that also, no problem. So whatever ratio you want to take, you can take. Now this is the next command. So from here I'm using Keras and I'm importing sequential because I am going to build CNN model. So I am again using, you can skip this portion, import numpy as np pandas at pd tensor for Keras, and but install this dense because we'll be needing dense. Drop out lstm because I'm gonna build a model of convolution neural network and lstm neural network. Okay, a hybrid network of CNN and lstm. So we're gonna use this lstm combo max pooling, flatten, activation, softmax, etc. And I'm gonna use atom for optimization. Okay, so this is a simple fixed command which we have to use as it is because we are extracting the function. Simple, nothing much. So now this is how we basically built our model. So first you define the model. Suppose your model is CNN. So you first define the model. It is defined. First you define the model. So model is sequential. Okay. In the model, first you add model.add. You are adding first convolution layer, which is 1D convolution layer, 5 and 15. 5 basically your filter, 15 size, stride 1, and the shape is 624,919, which we have already defined. Activation layer you are using in ReLU activation function. Then max pooling layer, which with the pool size 2, stripe 2. So earlier I have used dropout. You can skip that. If you want to use dropout layer, you can use that also. This is the second convolutional layer with activation function and max pooling layer. And again, I'm using LSTM of 32 units. Matlab means LSTM of size 32. Then I'm using a flatten layer to flatten it. Dense means dense, you all know, dense layer. Again, activation, dropout, dense. So this is my model. You see, this is my model. You can take whatever you want, no problem. However you want, you can take the model. So I am taking here, I'm taking my model this one. And for the last, we are using softmax, Adam optimization with a learning rate of 0.001, decay of 0.001. And I'm compiling, I'm using the loss, sparse categorical cross entropy. There are so many popular losses which we are currently, which we can use right now. Optimizer is Adam, matrix is accuracy, and you'll learn it. Okay, so this is your model. So we have defined the layers in my model. Now I'm creating the model. So this is a simple command to create a model, but it will give you error because as I said, there was some problem. And the error is this: LR argument not recognized, LR 0.001 LR. So I think nowadays we are using learning, not LR. So I'll just, because I can replace it as it is also, but I'll show you how to do this. So next step is explain error. I'll click that explain error. So this will explain the error. The new window has been opened. It will explain what is the error. Now the system has been very simple because everything is now been integrated with AI and Google is basically using Gemini. I'm running out of time. I'll try to wrap up it as early as possible. So it is working. So see, it is say, see, I was right. It is saying it's like the error is due to an argument LR and decay being used in the Atom optimizer, which is no longer supported in the latest version of Keras. I'll update the code to use. Yes, please update it. So which I have used LR now. Being LR is not being used. Now we are using learning completely. Okay, so it has been replaced. Now I'll run it again. Let's see. Again, there is an error. LR has been replaced, right? LR. Again, just a second. Let's run the cell again. Just a second. I have to run this again. LR. Yes. Yes, it's done. Okay. So see, now the system has become so easier to use. You can see the model summary also. This is the model summary. Yeah, so the first layer is the convolution layer. Okay, this is the output shape. Second is the activation. This is the output shape because we have taken the filter of 5 and 15. So this is the how your what total parameter which has been used is this much. 12.17 NB of trainable parameters are this, non-trainable parameters 0. Okay, so this is how your model looks using CNN and STM. Again, I'm importing because I'm running out of time, so I'll do it quick. Again, I'm importing model checkpoints and early stopping. These two functions we will be using while generating the accuracy, while checking the accuracy. Because I'll tell you what is this. See, this is the code. Before that, I'll tell you what is this. So in this code, what we are doing here, pat is equals to 4, which is the number of epochs to wait before stopping. So this basically this particular code which I am using is to sometimes what happened, you just define the epoch. Suppose I have defined I want to run my code for 100 epochs, which is not required. Suppose your accuracy is not increasing even after 50 epochs, and you are still just consuming the space or increasing the complexity, which is not required. So what I will do, I'll use early stopping. So early stopping will do, it will wait for few iterations, and if after few epochs also If accuracy is not increasing, it will stop there only. It will stop the processing there only. So here I'll wait for 4 epochs before stopping if there is no improvement. And I'm using early stopping, which is basically callback. That's which is callback that stops the training when it will monitor the validation loss. Okay. Now here we have monitor. We are monitoring validation loss and wait for 4 epochs. Verbose is one, which print the message when training stops. Okay. It will prevent the overfitting, because it is also a main problem when we run the code. It is also the main problem. Now then we have model checkpoints. It is basically calling the function to save the model during the training, because sometimes what happened that your training stops in between and your the whole process is gone. So it will basically save the model during the training only. Then we have FAS MNST 1.h5, which is the file name where I'm saving my model. You can use anyone which you want. Now we have save underscore best only, which will keep the best model, which with the best model means which has the lowest validation loss. And then it will print the message. Verbose one means it will print the message when the model is saved. Okay. Then we have define, fit and evaluate to train the your model, CNN model function that builds the CNN architecture. There are 100 epochs which I'm defining. So maximum training epochs are 100. It will stop earlier if the early stop happens. Okay. Batch size is 32. Then we have results is equal to, so I have called model fit. I'm assigning the values in the model fit to train the cn. We have t underscore x, t underscore y to training data features and labels. We have validation split of 0.1. 10% means 10% of the training data is used for validation. Then we are calling the early stopping and model checkpoints, which we have defined earlier. And then we'll store the results. Okay. Loss and accuracy per epochs. It will print the value score after training. It will evaluate in the final it will evaluate the final model on validation and test data set, which is value val underscore x and val underscore y, and it will print the valuation metrics. And it will result again return result. It will return to the result object which contains the training history. So we'll run it. We have already run it, I think. Okay. Now we'll take one more function, which is this date time. I will tell you what is this also. Okay, so now this is enfolds. So what I am doing, see, for training and testing, there are two options. Either you divide training and testing, 20%, like 80% training, 20% testing, or you use tenfold cross validation method. I think you know what is tenfold cross validation. So I'm using tenfold cross validation here, where I'm using tenfolds, 100 epochs, batch size of 32, and here I'm using this date time, which capture the current time, so you can measure the total your training time, because you should know now what is the training time. So this date time is basically to capture the total training time which was taken by the model. Then we have a new a list of with the name of model history, which will collect all the history objects which were at the training time, so that you can use later on to plot the accuracy and loss curves. There is a loop for I in the range n folds, which this loop will run 10 times. Since we have used n folds equals to 10, it will print which fold is currently being trained, like fold 1, fold 2, etc. Then it will split the data into training t underscore x, t underscore y, and validation valid underscore n and valid underscore y sets. Test size is 0.1. Again, 10% of data is for validation. Then random state used for random seed for each fold, so that each split is different. Okay, so there is no overfitting. Now it will call the fit and evaluate, which we have defined earlier. It will build the CNN, train it, save the best model with the checkpoints, and it return the history of the training. And it will print with the this line, print with these lines. So it is training. Okay, so as you can see, so rather than, because we don't have so much time, I'm stopping it here. I'm stopping, and I am using only one fold and only 3 epochs for quick. Or to show you different folds, what I can do, I can use two folds and only two epochs. You can use as many as epochs you want, because it will not consume your space, because you have already used early stopping. So if there is no improvement in the accuracy, it will stop in between, like 50 epochs or 80 epochs, however you want. But fold, because in major cases, majority of cases, we are using 10 folds. Okay, 10 folds cross validation. So majority, in major 99% of cases, folds. Okay, in some cases you can use 15 folds also. So basically in folds means, so you have a training data. Suppose you have a training data of 1,000 sets. Okay, so you are creating 10 folds of that particular 1,000 samples, and you are iterating those, so that there is no redundancy in this. So it has, see, training on first fold has been completed, because we have taken two epochs only. Now training on second fold has been started. So see, here it is like in validation loss did not improve from 0.21145. Validation loss did not improve from this. So it will keep on giving you this, because we have mentioned. Okay. Now training completed in time. This 1 minute 33 seconds. Now this is for plotting. We have already basically used the plot function from the library. So this is basically because earlier, here I'm only using two folds, and accuracy is not here, it is accuracy. So I'm changing it accuracy, otherwise it will give you error. And I'll see, there is your plot. So it is the plot of accuracy versus epochs. You can basically, you can plot for validation. You can plot your validation because you have seen papers that there are validation plots also. You can do that also. Oops, sorry. So I'll just delete 3. Again, this is accuracy, 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 accuracy. Just a second. Hold on. See. So now you have training accuracy for fold 1, validation accuracy for fold 1, training accuracy fold 2, and validation accuracy is fold 2. Okay, so you have already plotted your graphs for training and testing. You can find out the accuracy also, or if you want to find out the accuracy, just a second. I'll just give you, because earlier also at the time of running now, it was giving you accuracy. You can check from here also. Model evaluate on the testing data set. So in testing data set, wow, it is giving good accuracy, 0.749 and 4.41. So it is giving you accuracy and loss. Loss is this much, accuracy is this much on the test data set, because we have already trained. And this is, if you have time, I can cover confusion metrics also. Otherwise, this is still. Amit sir, is this okay? Or do we have more time so I can cover confusion metrics?
Uh, I'm not sure if means participants are okay, then I don't have any issue. Can you complete the confusion matrix in 5-10 minutes?
I'll try. Sir, speed. I know I have covered the last portion also at very much speed, but I try to cover each and every line. Yeah, I'll try to cover confusion metrics also, if everybody is okay. Otherwise, if
Yes, participants,
as you suggest.
it's completely up to you. If you are ready enough to means sit for another 10 minutes, then I am okay. Anu is saying okay. Okay, madam. Okay, then means participants are okay. Then maybe you can complete in 10 minutes. Okay.
No, no, it will only take 5 minutes, sir.
Okay, okay, okay. Thank you.
Okay. So again, this is from SQL and metrics. I'm importing classification report and confusion metrics function, which will be using for confusion metrics purpose. Then I'm importing SNS. So I'm importing SNS. This is for Seaborn library. Okay, Seaborn library is a data visualization. It is a data visualization library to visualize and to make beautiful plots. Because confusion matrix, obviously, it will take some colors and all. So now this is a function for confusion matrix. This is a confusion matrix. So I'm defining a confusion matrix which has true and this confusion matrix predictions, true predictions, SNS heat map because it will generate the heat map. Prediction. It is basically test prediction and then labels. It is basically not required. If you want, you can skip this portion, no problem. You just draw it because you want to know how to convince. So this is, see, you just print the classification report, test Y, test prediction level, and it will give you this accuracy. This is for precision, recall, F1 score, support, and it is giving you all the, you can draw the confusion matrix also. For drawing the confusion matrix, simply use draw confusion matrix function. Just simple. Yeah. So this is here. Yeah, it is giving you confusion matrix. So if you want, I can cover this also. Yeah, this key, what is happening here, how we are basically because we are in hurry. So I just showed you the confusion matrix. So what is happening here? Just a brief. So here I am defining this confusion matrix name with the name draw confusion matrix. It is taking two inputs, true for the true labels, which is for the like true labels, and because obviously confusion matrix is between the what is the value and what is the predicted value. So true value and the predicted value. Then we are calling the confusion matrix function from the sklearn matrix, and then we are creating a confusion matrix here. We are creating a confusion matrix which is a 2D array which has the true labels and the predicted levels, which has the rows, which has the actual classes, column for the predicted classes. Okay, and then which is now the next is the SNS heat map, which is the Seaborn heat map again, to make the confusion matrix visually like very good, like it will look very good. And there is true will not true. A not true means it will show you the number inside each cell. A not KWS, which is size 12, it will say it is for annotation ka font size fix karne ke liye. So annotation font size is 12. You can change it whatever you want. FMTG is the format the integer how you want it. Then C bar is false. It will remove the color bar on the sides. So it is my way of generating. You can use. So it is available on. You can take the help of Gemini or Google because it will give you that how you want to generate your confusion matrix. It is for visual purpose only. Then plot show. So it will display the plot. Now this defining. Just a second, I'm getting a call. Yeah, this one. Defining preparation submission prediction array file name in abc.csv, because this is simply because I have saved with this name. So you are adding the axis, x-axis is equals to predicted, y-axis actual. You are accepting the classes, whatever. Suppose I have two classes, normal and schizophrenia. For better readability and figure size, you are drawing. Then we are drawing the confusion matrix. Simple. So this is your output. Is this clear? See, if you have any doubts related to the code or function or any line, you can contact me. I'll help you because we have a very sort of a short of time. So I just try to cover it as soon as possible. But if you have any doubt related to, see, now as I showed you, now it is basically integrated with Gemini. So you just write, generate, and it will help you. But again, if you have any doubt or with the concept, or you can contact me or sir anytime, and I'll be happy to help you. Thank you. Thank you so much, sir. Thank you.
Thank you, Gitanjali, for a wonderful session. I think students have benefited it out of it. Any question if you have, then quickly maybe we can have a any 2-3 question. Other means okay.
Yes, yes, you can ask anything, no problem.
Yeah. So means they will type in the chat box only because they can type only right now. No question. Okay, so it seems that currently there is no question. If at all anything is there, then maybe you can contact the Gitanjali, because I already said the mail ID to all expert with them. Okay, so they can contact at any moment. So thank you, Gitanjali, for a very good session. And
Thank you
with
so
this,
much, sir. Thank you for giving me the opportunity, and I'm ready to help. I'm happy to help because I know it is very difficult when you start on this field now.
okay, okay, thank you. So with this, students, we are ending up our day 6. Okay, for this week. So tomorrow there is no as such lecture, but definitely we have a quiz, as I announced that morning 10 to night 10 p.m. So there will be a 15-minute quiz where 20 questions will be there that you need to attempt according to whatever the free time you get it. Okay. But I believe that 15 minutes you can at least make out from your tomorrow Sunday busy schedule. Okay. So thank you all of you. See you on Monday at 5 o'clock again. Have a
Okay, sir.
nice have a nice Sunday.
Have a nice Sunday. Thank you.
No, quiz will be of 50 minutes only. I think 15 minutes is also higher. You can complete it within a less than 10 minutes. But 15 minutes I am keeping set. Okay. So 15 minutes. Once you start, then it will last for only 15 minutes. So in order to avail the 15 minutes, you need to start at night 9:45. Then and then you can get the 15-minute slot. Okay.